Hi guys, welcome to the first video in the dynamic programming series. In this series, we shall be solving a lot of dynamic programming problems and we'll solve them by first drafting up a brute force solution and then see how to optimize it using top down and bottom up approaches. Generally, when you go on searching for the DP problems on the internet, whether it's Geeks for Geeks or any other site, you'll usually end up watching the most optimized solution in the beginning itself. So, in dynamic programming, it gets really confusing sometimes to some of the problems as to how you got to that optimized solution. So, what I intend to do is we'll give for all the problems that we see. We'll first start with the brute force solution and then try to see what is the problem there, optimize it using top-down approach, and then finally invert it down into a bottom-up solution to get the most optimized solution. Coming to what is dynamic programming and why do you need it? Coming to placement perspectives and competitive programming, in almost all the competitive programming contests and even in lot of placements, almost all the companies ask you at least one dynamic programming problem. And even when you're solving real world projects or any real world problem that you're applying, when you need to optimize it, when you find certain patterns in those problems, you can improve the time complexity by a huge extent using dynamic programming concepts. Moving on to solving the DP problems, where we'll first understand and build the brute force solution and then we try to approach it towards optimization. This kind of way of approach will actually help you a lot in your interviews, where whenever the problem is given to you, you will kind of draft out the brute force solution and then improve it. So that is very valuable for an interviewer. Okay. Not only that, if you go on practicing dynamic programming problems, you will also find that the problems that involve recursion, the problems that involve subdivision and using the solution to small subproblems to get the solution to bigger problems, all these kinds of problems becomes very easy once you start doing DP problems. Alright, coming to the main question of the video, what is dynamic programming? Dynamic programming is a programming paradigm or approach to solving some of the problems, where the nature of the problem is such that you can kind of divide the problem into smaller subproblems, and once you get the solution to smaller subproblems, you can find the solution to the given problem by combining those smaller subproblems solutions. It's called dynamic programming because when you solve your smaller subproblems, you kind of store the results. You cache the results onto a data structure. It can be an array or a map or any kind of data structure. And whenever you are asked to solve the same problem again, you will use the solution that you have already stored and directly use it. So it's called dynamic programming because you do this in runtime. You store the results of your small subproblems, and while solving the same problem itself, you will be needing the solutions for all those subproblems multiple times. So you will be caching the results first when you are solving and then reusing the cache multiple times. So that is the idea behind dynamic programming. This storing up of your solutions into memory will increase the memory space required, but it will hugely benefit in terms of time complexity. Anyway, we shall be looking into all these approaches, all these methods, and the implications of using dynamic programming in the future videos when you actually start solving the problems. Just to give you an example, here I have written the function for Fibonacci sequence, where nth Fibonacci number is equal to the sum of n minus 1 and n minus 2th Fibonacci number, and this is the base condition. Okay, so if you think of this problem with a given problem is an input of n of size n, let's say, so you need to find the solution for this given problem. Now you can divide it in such a way that you can first divide it into smaller subproblems. See, this subproblem is of size n minus 1, this subproblem is of size n minus 2. So these are smaller subproblems, and you find the solution to smaller subproblems. Once you find the solution to smaller subproblems, you will kind of combine them. This combining of smaller subproblems depends on the actual problem and how your understanding of the problem is. Okay, you will combine them to get the solution to a bigger problem. And when you are solving the subproblems, you will go on storing it in your cache. And the next time when you need the solution to the same problems for the same input, you will reuse the results that you have stored in the cache. Okay, so this is the whole idea behind DP. The idea is simple, but sometimes the problems can get confusing. And anyway, we shall be looking into a lot of problems, and it will be very clear once you get through all these videos. Okay. Hope you guys found this video useful. If you did, please like and don't forget to subscribe. See you guys next time.